What makes it go? And don't say ask a mechanic, because if you know just a few fundamentals of how your engine turns gasoline into power and how that power gets from your engine to your wheels, incidentally identifying a few major parts and what they do, you're less likely to get stuck in embarrassing situations. You'll make much more sense to a mechanic and become an authority to your less knowledgeable friends. Remember, these things we'll cover are fundamentals. Some of them you'll already know, but perhaps you can gain by seeing how they work together with other things that may be less familiar. And anyway, it's only 10 minutes out of your life, so here we go. Let's begin with the car's power source, its engine. Gasoline and air mixed together form an explosive mixture. The basic job of the engine is to convert this explosive energy into motion. To contain the explosion, the engine uses a cylinder, and fitting snugly within the cylinder, a piston that slides up and down. Inside the cylinder, an electric spark ignites the compressed gasoline and air, and the hot gases from the explosion push the piston downward. The piston rod is connected to a crankshaft, which converts the up and down motion into rotary motion. The crankshaft then drives the rear wheels through various machinery, which we'll see later. Here is a different perspective on how the piston drives the crankshaft through the connecting rod. At the top of the cylinder are the valves, which let in the gasoline and air mixture. For increased power and smoothness, modern auto engines have a number of cylinders driving one crankshaft. Gasoline from the tank is pumped by the fuel pump to the engine's carburetor through the fuel lines. The carburetor mixes the gasoline with air to form the explosive mixture that drives the pistons. Here's a closer view of the carburetor. A linkage connects the accelerator pedal with a valve in the carburetor. Stepping on the gas opens this valve wider, increasing the gas flow and speeding up the engine. Easing off on the pedal reduces the flow and the engine slows down. Here on an actual engine are the counterparts of the fuel system just diagrammed. The fuel pump, the fuel line from pump to carburetor, and the carburetor itself with its air cleaner removed. Here is the linkage connecting the carburetor to the accelerator pedal. The engine's electrical system supplies the spark that fires the fuel mixture. As the engine rotates, it drives a generator which keeps the car's battery charged. The battery supplies electricity to the coil, which boosts the current to a voltage high enough to produce a spark, and then sends it through the distributor to the spark plugs located in the cylinders. The distributor distributes electrical current to the proper spark plug at the proper time. Inside the distributor is a rotor, which as it turns touches a series of contacts, one of which is wired to each spark plug. The points open and close as the rotor turns, interrupting the current to produce the fuel-igniting spark. Here again are the major parts of the engine's electrical system: the generator, the battery, the booster coil, distributor, and spark plugs. Now looking at an actual engine, here is the generator and the battery. Together at the rear of the engine are the coil, the distributor cap containing the contact swept by the rotor itself, and the points, which sometimes need adjustments. And finally, in the cylinder heads, the spark plugs. The engine on this model chassis contains nearly all the parts found in a working engine. Let's break it down to its fundamentals and then build it up again. Here's the heart of the engine, the cylinders and pistons. This engine, known as a V8, has two banks of 4 cylinders each, driving a common crankshaft. The camshaft, geared to the crankshaft, lifts and lowers the valves in the cylinders. Now the right and left cylinder heads containing the valves themselves and the valve lifters. The distributor at the rear of the engine is also driven from the camshaft. Now the fan, the generator, and a part of the cooling system. Here, flashing lights simulate the firing of the spark plugs as the rotor supplies current to each in proper firing order. Continuing the build-up, here are the carburetor and the manifold. And finally, the air cleaner atop the carburetor. Here is a rear view showing how the pistons drive the crankshaft. And down through the plastic housing, we can see the gearing connecting the camshaft to the distributor. 4, 6, and 8-cylinder engines are standard today. This V8 configuration is very popular for its smoothness and power. Well, now we have an engine. Before we have an automobile, we must add a way to transmit the engine's power to the wheels, provide for supplying different amounts of power for starting, climbing steep hills and the like, and devise a means to stop the car. The machinery that transmits power to the wheels is called the power train. From the engine, these include the clutch, the transmission, the drive shaft with its universal joints, the rear axle, and the differential. A problem with early automobiles was how to keep the engine running while the car stood still. This is done by the clutch, which is basically 2 discs, one of which is attached to the engine, the other to the transmission. When the discs are held apart by pressing the clutch pedal, the car stands still. When they are brought slowly together, the car starts to move. Next in the powertrain is the transmission. By bringing different gear ratios into play, this car can be placed in low to start, shifted to second to accelerate, and put into high once cruising speed is reached. In most cars today, the work of both transmission and clutch is done by an automatic transmission, basically a fluid coupling and speed-sensitive shifting mechanism that simplifies driving to stepping on the gas to go and on the brake to stop. The drive shaft transmits the power from the transmission to the rear axle. This shaft, while rigid, is connected at either end by universal joints, and these allow it to bend, so to speak, while revolving. The drive shaft in this cutaway chassis has an extra universal joint in the middle to reduce the height of the tunnel running through the passenger compartment. The drive shaft transmits power to the rear axles through the differential. The rear axle is in 2 halves, and the gears inside the differential divide the power between these halves according to road conditions. For instance, in a left turn, the right wheel must travel further than the left, and so must turn faster. The differential compensates. Similarly, in a right turn, it lets the outside or left wheel turn faster. Stopping the car employs a hydraulic brake system. Pressing the brake pedal pushes a plunger into the master cylinder, which in turn forces the hydraulic brake fluid through the brake lines running to the 4 wheels. The pressure transmitted to the wheel cylinder forces the brake shoes against the inside of a drum attached to the wheel. The resulting friction brings the wheel to a stop. Here is a model of the brake system using water as the hydraulic fluid for this demonstration. The hydraulic system tends to equalize the braking force between the 4 wheels and multiplies the pressure of the driver's foot for easy braking. A very small amount of travel is needed to bring the brake shoe into contact with the brake drum. We have looked at the basic systems of the modern automobile. The engine, which converts the energy of the fuel into rotary movement. The powertrain that transmits this movement to the car's wheels. And the brake system that enables the car to stop. Of course, literally hundreds of variations and improvements on these systems are found today. Power assists, safety devices, ways of getting more power and efficiency out of the modern car. many ways to make driving easier and safer. Still, the fundamentals remain much the same and are unlikely to change in the near future. In case of trouble, understanding what makes it go can save time, trouble, expense, and hazard, and give you a lot of satisfaction. The satisfaction of being in charge of your car.